Welcome back. Today what I'd like to do is mix things up a little bit and talk about the idea of progress. A lot of what we do on this channel is heavy duty theory as it pertains to finance, statistics, computer science, data science, AI, what have you. And I want to point out that a lot of the different tools and techniques from traditional statistics can help really quantify and explain things that we try to do in our daily lives, not just in the context of P&L and trading and coming up with some sort of neural networks loss function whose converges for a particular type of classification problem, but rather the overarching idea of goal setting and progress can be essentially quantified as a time series. And I wanted to discuss this idea today with an example of what it looks like in this accumulation process to essentially achieve some sort of goal. Now, if that sounds abstract, bear with me because I'm going to give you a practical example here. And really, the practical example can be anything that you are trying to do. It doesn't have to be quantitative. We love numbers because it is essentially showing progress if we have an increase and regression if we have a decrease. But if you take something like I compete in Brazilian Jiu-Jitsu, for example, how can I quantify my progress? Just because I beat somebody else, does that mean that I'm better than I was yesterday? If I know more today, does that make me better than I was yesterday? Well, clearly, if I train for a year and I go a couple times a week, then I'm going to be better than I was last year. But what does that actually mean? What does that look like graphically? That's essentially what I'm going to show you today. Now, if we're talking about something that is easily quantifiable, like a timed run, then this is going to be even more applicable. If we're talking about something like weight loss, take this accumulation process that has a positive trend over time and make it negative. It's going to be the exact same interpretation. So my point is, you can quantify progress even if it's intangible, or at least interpret it in this way, graphically. So let's take a look at this data here that I've generated. So the first column is an actual realization. Let's say I weigh myself this morning and I'm trying to lose weight. That could be a realization. Let's say I run a mile today and I get a time. That could be a realization of the data. And what you have to realize is that this realization is pretty noisy. Now, what do I mean by noisy? Well, that may not be an accurate representation of the true level or the true expected level that you are currently residing at. If I go out and I run a mile right now at 6 minutes, does that mean that that is the best performance that I have? Or am I operating around a certain level with some give either way? Same thing with weight. If I have a weight of 200 pounds this morning, that doesn't necessarily reflect the true level that I'm at. What if I drank a lot of water before I weighed myself? All of these things play a factor into our interpretation of this realized data point. Now, the fortunate thing for us is we can accumulate these data points over time, and we can take the cumulative mean and the cumulative variance. Now, the cumulative mean is hopefully going to give us an insight into the true level in which we are actually realizing data points about. So if I am roughly 200 pounds and that's my true level, then I'll expect some give either way on any given day, but my true level is 200 pounds. If I run a mile in 6 minutes, I might expect give in either direction on any given day, but I know my true level is around 6 minutes. What does this mean for progress? Well, progress doesn't have to be linear. Progress also can look like regression. And I want to explain why, because it can be incredibly frustrating when you step on a scale and you see the weight increase, when in reality it is part of the process of progress. Okay, let's take a look at our first chart. This is a cumulative analysis of progress at time t equals capital T. Capital T is the end goal here. Let's say our end goal was 25. So this could mean anything. This could be maybe I wanted to work my way up to 25 reps at a certain weight. Maybe I wanted to work my way up to 25 pounds in the gym. Maybe I wanted to work my way up to 25 rounds of sparring. This could mean a variety of different things. This could be any goal in which you set. Now, if this was weight, we would hope that this scatter plot would trend downward. But I don't want to focus too much on the actual example here. This could be any goal in which you set for yourself. I want to talk specifically about the analysis. Now, to put it in relatively reasonable terms that is easy to interpret, we'll talk about test scores. So I want to keep in mind that this doesn't have to be strictly quantitative. This could be qualitative as well. Your progress does not have to be easily quantifiable for this chart to apply to the goal in which you are progressing towards. But let's take a look at each of these red dots as a practice test. And let's say that the score that we are trying to achieve is a 25. Well, when we start out, we're starting out at roughly a 10. But each test has a random set of questions. Our priors may influence our ability to answer those questions. If I have an engineering background, then questions about probability and statistics and mathematical questions are going to be easier for me to answer rather than perhaps qualitative questions about English or history. But as I continue to study, as I continue to improve, and I take more practices, you'll see that these red dots start to realize a bit higher. Now, right away, I take a 10 and then I jump up to like an 11. Then I jump up to like a 14, then I go down to like a 13. So these realizations are random over time, but just like we said, how there's given any direction for a mile that I run, or there's given any direction for my weight on a given day, what we really need to do is analyze this progress over time. We're trying to analyze this true level over time. And progress is measured by an increase in that true level. It's not any particular score. If I jumped from a 10 to a 17, and then my true level is really 13, if I continue to take tests, I'm not going to get to that 17. So clearly here, we would not expect a performance of a 17 on that test. Now what I've done is I've also plotted the cumulative mean, which should represent the true level that you are currently residing at, along with the cumulative variance. So what this means is, as time progresses, you'll see, okay, these red data points are starting to trend up. What else is trending up is this cumulative mean that is hopefully a representation of your true level. Now, what you'll notice is the variance window tends to increase over this time frame. Now, why is that? Well, you can see that over this time frame, there's been significant deviation from this initial score of 10. Now, that's what we want, because that's what represents progress in this case. When these red dots start to trend upwards, we're increasing the score on our test. Now, the problem with this cumulative measure of mean and standard deviation is, hopefully you can see here, all of these red points are above this cumulative mean, except for this one, which is on the cumulative mean, and these earlier points that are below it. But you can see that this cumulative mean trends upward over time. The problem is there's this non-stationarity in the mean. This cumulative mean over time is not a good representation of the level that we're at time 40. If it was, then these points would be distributed about this cumulative mean value. Now, the upside is if this cumulative mean value is positive in terms of the trend, then that means we're improving in the context of this problem. We want our test scores to improve. Now, what you'll also notice is, does everybody see the variance here? The variance tends to be significantly wider, but we have upside variance that's contributing to this massive considered downside variance with respect to the cumulative mean, which is just not the case. In other words, we've been testing around 20 since it looks like early 25. We've been testing around 20. So clearly, we're not going to expect a test score to be 15, 10, or even below 10 at this point, even though we have this upside deviation. We don't want that to contribute to the downside deviation in trying to understand our progress over time. So essentially what I'm saying is, if we take the cumulative mean over time, and that trend is positive, that's a good thing for us. That's a good thing for our progress. And in fact, as these data points realize, we could see the trend for these data points is overall positive, but our measure of variance seems to be wildly incorrect because we're not expecting any test scores below 15 past 40. That does not seem to be representative of what actual test scores we are practicing at. So what can we do to better offset this? Well, in terms of time series analysis, this non-stationarity means that we can't use the cumulative mean because over time, our level is changing. That's what quantifies progress. So instead of a cumulative analysis, I'm going to look at a windowed analysis. Now, when I look at a windowed analysis, I have a 7-period rolling mean, and I'm looking at plus or minus 1 standard deviation away from this rolling mean. And you'll see, hey, this is actually a pretty good representation of the spread in our realized data points about the current level in which we're operating. So let's say that I'm testing currently around period, let's say 7. I'm testing around 14, plus or minus 1 standard deviation above or below this mean right here is going to be a representation of the spread on any given test around this time that I can expect to receive a score. So what I mean to say is if I'm currently testing on an average of 13, then plus or minus 1 standard deviation away from this mean is a reasonable approximation of how much on a great test at that time I can expect and how poorly on a bad test I can expect. So essentially here I'm looking at, okay, well at time equals 7, I'm testing at a level of roughly 13. But on the upside, I realized the 16 here. That has no bearing on my current level. My current level really is closer to a 13, 14. But maybe I did particularly well on that test. Maybe that run I was feeling really, really good. Maybe I just so happened to not drink a lot of water yesterday. My weight declined more than it should have. My run was faster than it should have been, representative of my true level. So that's contributing to the overall variance. Now, on the flip side, maybe there were concepts on that test that I didn't understand. Maybe I drank way too much water yesterday or ate too much food. Maybe I'm feeling super tired on my run. That contributes to downside variance. There's too many factors at play. But what we do know is this true level here is representative of our current progression. That is, you can see as we progress through time and we take this rolling mean, so we're only taking the mean of the past 7 realizations at any given time, you can see that this positively trends up significantly more than the cumulative mean, which is weighed down by earlier observations. Moreover, I want you to notice something very specific about the variance window, and this is what contributes to a significant amount of frustration in progress, and that is if we are at time 7 and I realize this 16, so I've been studying, I get a 16. What about my next test? I'm down to 12. Then I'm down to 12. I'm at the bottom of my variance window here. Now, does that mean that I'm not progressing? It does not. It does not mean that I'm not progressing. In other words, I'm still progressing. I'm just realizing points at the bottom of my potential. That doesn't mean that I don't have significant upside potential or that my true level is not progressing in a direction that I want it to be progressing in. In other words, you'll see I tested at the top of my variance window here, then I test down, I start to test up, I test down again. Imagine if this was weight loss over weeks. Talk about the frustration. You dropped 5 pounds, then you gain a pound, are neutral, maybe you gain half a pound, and then boom, up here you drop more weight, So that's what I'm trying to say is this progress that you're accumulating over time is in terms of this rolling window, this level. And you can contribute it pretty similarly to the idea of accumulating positive expected value over time in trading and finance. Now, if that means nothing to you, your progress alone is this black line. This black line is going to continue to trend up as you do things that move you towards your goal. You train every day. You eat appropriately every day. You run every day. You lift weights every day. You study every day. That's going to get this black line to trend in the right direction. Now, this variance window, that is your potential upside and downside on any given day, that is always going to be a factor in whatever it is you are doing. So if I'm trying to weigh myself tomorrow, there's going to be some variance. That is, there's some deviation away from that true level that I'm sitting at. If I'm testing tomorrow, there's going to be some deviation away from what I'm currently testing at. Now, if I'm fortunate and lucky and the circumstances are on my side, then in the short run, I'm going to have upside deviation. If I'm not fortunate, then I'm going to have downside deviation. And that is a function of way too many factors to be able to play into a very basic model like this. But overwhelmingly, the progress is trending in the right direction. But hopefully now you're starting to see why the progress is nonlinear, why it's frustrating in some capacity, especially if you're working very hard. How do you know it's extremely frustrating? Well, we don't have this chart. This is the chart of progress after you've put in all of the work from 0 to time 40. This is the cumulative chart from 0 to time 40. You're looking at a chart, let's say you just started progressing towards a goal, you're looking at a chart that looks like this. It looks something like this. And imagine the frustration that you've been doing this for maybe 10 days, 10 weeks. The units of time themselves are arbitrary, but you start to see an improvement to 14, 14, 13, 15, 16, and now you're testing down again to 12, 12. But you're like, oh man, like this is week 8. I was starting from 10. But we don't have a cluster of points here. 10 could have been the top of your variance window. The true level could have been way below 10. In reality, you've progressed. If your true level was, if you were operating at the top of your variance window, then your true level was even below this. Your true level could have been a 7. And you've accumulated this progress, but you don't see it. So all this is to say is, whenever you set a goal, whether it has quantitative metrics or qualitative metrics are much more difficult to actually measure progress toward. It doesn't matter, essentially, is what I'm saying. This picture, this graph, this interpretation is how you should visualize progress. Even if you can't realize these data points over time, even if you can't take a practice test, can't weigh yourself, can't go on a run and time yourself, whatever it be your goal, this is what the interpretation of progress over time should look like. You're going to have some variance around the level that you're currently operating on, and every step that you take towards your goal is going to increase that level, and that variance window is always going to be there. Now, there may be other factors that you can implement to decrease or increase your variance window. So, for example, maybe I have no nutrition plan when I run. Well, clearly, some days when I eat a lot, the variance is going to be much higher. Maybe I eat really poorly or I eat really well. That's going to be higher. Maybe I eat more consistently. That's going to contribute to a narrower variance window. All of this is open to interpretation and discussion. But it was very important that, I wanted to kind of branch out and apply the mathematics to something that's a little more tangible in everyday life, because I think we all have goals. We all have things that we want to achieve. And progress is a very confusing idea. It doesn't have to be fitness oriented. It doesn't have to be academic. It could be anything. It could be progress in relationships, interpersonal skills, things that don't have quantitative measures. They will still evolve over time in this capacity. Lecturing for me is a very good example. When I first started lecturing, it was a mess. I had to have kind of a script. I had to know what I was going to say and where I was going to go. But year over year, as I've continued to discuss different ideas, math, code, statistics on the spot, answering questions extemporaneously, that is what contributes to my success as a lecturer and the development and progress over time. I can't measure that, but I do know on any given day I may deliver a wonderful lecture, or I may deliver a terrible lecture relative to this true level in which I reside at, that black line. Now, the important thing for me is year over year, I know that that black line has been improving. How do I know? Because I haven't been able to quantify these red points. Well, take a look at my videos from years ago. Take a look at them now. If I told you years ago I needed a script to be able to write a video, to be able to record a video, versus now where I just hop in front of a camera and coherently put together ideas that essentially articulate what I'm trying to get across to my viewers, well, I would say that that's the black line going up and to the right. Thanks for watching. I hope you enjoyed this video, and I'll see you in the next one.